Okay, so today we're going to finish up 2.3. To start though, I'll just run through this as a warm-up, and then we're going to do number 8. So make sure you have out your homework, okay? So this is a review I don't know what I'm doing here. Okay, this is a review real quick of a long division. Why do I have to do this by long division? Can somebody tell me? Yes, on this divisor guy out here. Yes, or it has to be x plus or minus c in order to do synthetic division. Yeah, it's jumping around on me, but it's kind of working here, so I'll go with it. So long division, how do I make 3x become exactly 3x squared? All right, so 3x to become 3x squared, we had to multiply by an x. X times this whole quantity out here gives us 3x squared minus 2x. Then why does everybody get the next step wrong?
Because I just take away negative 2x and it should be adding it.
Okay, they do forget that we're subtracting this whole quantity or adding the opposite, which, yep, that's not working, makes this 6x minus 12. We would need to multiply by what? Positive 2. So we would have 6x minus 4. Then if we add the opposite, yep, that was clearly where I meant for that to happen. We get negative 8. So we could write the remainder as plus negative 8 over 3x minus 2. All right, so now the second thing I have here today is this is number 8 from the homework. I don't know if anybody did their homework, but you were supposed to divide this. But then the direction says factor each completely. So I'm going to run through the division, which somebody who did it on their homework maybe can help me. What would we need first? Okay, x squared. So we'd have, let's try this. So it's not recording the right thing, you think? All right, so x squared made this x to the 4th minus 4x cubed minus 12x squared. Then if I changed some signs so I could just add, this became 1x cubed minus 24x squared, bring down the plus 68x. Okay, what do I need to multiply x squared by to get a positive 1x cubed? One x, everybody okay? 1x times this whole thing will give me a 1x cubed minus 4x squared minus 12x. I'm going to change signs again and add because I don't like trying to remember to subtract. So that gives me negative 20x squared plus 80x, bring down the 240. Okay, x squared times what will make it exactly negative 20x squared? Then if I distribute through there, Cameron, what would I get? Negative 20 times all three of those terms, do you know? Negative 20 times negative 4, yes, times these guys. Yeah, so I think we're good, right? We have no remainder? Did someone else get that? If I go through and change all the signs, that all becomes 0. All right, the question said completely factor this. Does anyone know where it wanted to go with this now? Exactly, thank you. Because this factors how, guys? X plus 5, x minus 4, does that work? Okay, but it was divisible by this, right now, if we were checking this problem, we'd have x squared minus 4x minus 12 times this answer, right? So if we can factor that one too, we'll have all the factors.
X minus 6.
Anybody disagreeing? Okay. If I graphed that, what should I see? If I graphed this fourth one? Where would there be zeros, guys?
Go.
-2, 4, and 6. Okay. And it was positive, so it would go cross, 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 cross. I have no idea how far up or down it goes, but that should be the right shape.
We have to go on.
No, not at all. I just wanted to tie all that together because that's going to lead into today's lesson, okay? All right, now I am going on to the back of your worksheet. We're going to come back and do some more homework in a minute. But the back of the worksheet 5B, is that right, guys? Is that where I am? Okay, so the remainder theorem, it is kind of funky. It says if you divide by x minus c, the remainder is the same as f of c. Okay, so if we want to know what the remainder was going to be for this, yes, no. Okay, let me keep going. Sorry. I'm glad I'm recording this in Abruzzo. Students are supposed to watch it too, so. As I mumble through this, okay. I just thought there was an example I could point to real quick. Here's an example, but it says, the number of tickets sold during the Northwood High School football season can be modeled by this disastrous equation. Okay, where X is the number of games played, and that will give us the number of tickets sold. It says, use the remainder theorem to find the number of tickets sold during the 12th game. So the easiest way in my brain would be to just put the 12 into the function and be done with it, right? But they're saying, well, that's really complicated. Another way you could do that is do synthetic division with a 12 there, and this remainder will be the same answer as if you had put the 12 into the function. That's what the remainder theorem says. Not in my opinion, because we have a calculator, but it says if you want this to be a factor, it means the remainder has to be 0. Means it goes in evenly. Does that make sense, everybody? It's a factor if it goes in evenly, okay? The other thing you could do is plug the value, the 0, in and see if it comes out 0. Because if it goes in exactly, it's a 0, which means it's an x-intercept. All right, so that's kind of a complicated way of doing this. It says, your example here says, determine whether x minus 2 is a factor. Now, honestly, if I had to determine that, I would have done synthetic division, because I would want to see, everybody with me, 2x cubed plus 5x squared minus 14x minus 8. You remember that the 0 is what goes in the box up here? Okay, then what's the rule? First one does what? Drops down, and then we multiply, add, all the way down, or across. So 2 times 2 is 4, 5 plus 4 is 9, 2 times 9 is 18, negative 14 plus 18 is 4, 2 times 4 is 8, we add and get 0, so is x minus 2 a factor or not? Yes, it's a factor. And why? The remainder equals 0 would be one reason. Okay. The other way you could have done this problem is what they're trying to tell you here is you could have put a 2, which is the 0, into the original polynomial. Somebody type, please. 2 times 2 cubed plus 5 times 2 squared minus 14 times 2 minus 8. Now do you see why the synthetic might have been easier? Because we could do it in our head a little better. but you have a calculator anyway. This would be 16, 20. So you'd get 36 minus 28 is 8, minus 8 more, and it came out 0. So it is a factor. Everybody okay? Because it went in evenly and came out 0. How could we check our answer back on number 4 on the front side of the worksheet? Yeah, I wonder if I even have that question here. Anybody tell me what number 4 on the front side said? Or they wanted us to do this, right? Okay. So the question is how to check our answer besides doing the division. Anybody know? We could do synthetic, which may be what we did the first time. I don't know, because this one is syntheticable. But what would be the option besides doing synthetic? Do you remember what we just said? Yes, find f of 1. So if I did 1 to the 4th minus 3 times 1 squared plus 12, I didn't use parentheses because it's positive. You should probably, but it won't matter. And I got 10. Was that our remainder, guys, when we did it?
Yes.
Okay, it was our remainder. That was our remainder, so that's a check. Does everybody see what I'm trying to tie together here? The remainder will equal what you get when you put the function in. So there's ways to check these. Okay, moving on. This says use the factor theorem to determine if the binomials are factors. So they want us to decide if these two up here are factors. So they did synthetic division and found this one had a remainder of 48. So x minus 1 was not a factor. Everybody good? And they did -3, so x plus 3 was what it started as. That had a remainder of 0, so that was a factor. Moving on, you have this question. We are given that this, you don't have this number 7? What does number 6 say? I'm struggling today.
Minus 3x squared minus 6x plus 2 and c is 4.
Does it say what we're supposed to do?
Is x minus 4 a factor of x?
Hang on. I feel like we actually did this question already. Is it that question? Or no?
No.
It's not that equation? Okay. Another striking video from my day. Okay. Is x minus 4 a factor? Do you want to put in a 4? Or do you want to do synthetic division? Using synthetic substitution. Okay. Well, I think that means they want us to put it in. So 2 times 4 cubed minus 3 times 4 squared minus 6 times 4 plus 2 equals question mark. Somebody help me. I think this is 128 minus 48 minus 24 plus 2, 72, 56. Is it 58? That's what, oh my gosh. I don't know how I got that right. Okay. So 58 is what we get. So is x minus 4 a factor? No. I probably would have done synthetic division, but how do you know it's not a factor?
Well, where do you get that number?
This is question number 6 on the worksheet. No, we're not doing 7 yet because I messed up. Yes, because I messed up. Okay, so this, yes, sorry. So I'm going to take this and cut it off there so it's not confusing. And I'm going to add a page, put this on, and here we go for number 7. Yep. All right, so they want to know to determine if the binomials are factors. Okay, so what are we going to do? Do we have to do long division? No. So what goes in the little box if we're going to do synthetic? -5, which is the 0 for this that they want us to determine if it's a factor. Across the top, we have 1, -2, -29, and 30. No placeholders needed, right? Okay, the last one is going to be our remainder. Bring down the 1. Multiply. Go ahead. -5. Add. -7. Multiply. 35. Add. 6. Multiply. -30. Add 0. Okay, so did we just find out that this is a factor? So we could say factored form is x plus 5 times, I'm not going to write that on the blank till we're done factoring it. What is this again, guys? Just to review, this is the remainder, this is the constant. So this one gets an x for the linear term, and this one get an x squared. We made a plus back here. So after we divided by that, we had x squared minus 7x plus 6. Okay, can we completely factor that now? X plus 5 and we're factoring this one. Minus 6 and minus 1 will work. Look at there. We were able to completely factor a cubic that we had no idea how to do. I would not have known how to factor this, right? It's not a grouping problem. It doesn't work, unfortunately, for grouping. All right, moving on to part B. This is what will be on a quiz eventually. This is an extra example. Do you have this example? Okay. It's up to you if you write it down. It's like a homework question. We're going to learn a new vocabulary word. It's called the depressed polynomial. He's so sad. Okay, we're going to do synthetic division. Which one of these do you want to do first, guys? It doesn't matter. The 5, okay? We're going to do the 5 first. If we go across the top, I would have 2, -1, -41, and -20. Okay, help me with the calculator, guys. Bring down the 2, and I get 5 times 2 is added, times 5, added, times 4 is times 5 is 20, no remainder. Okay, this guy right here is called the depressed polynomial. Yes, this 2x squared plus 9x plus 4, okay? Now, we did this one already. We're supposed to keep going with the next one. What is the next one going to be in the little box? -4. Can I just not rewrite that? You get that 2, 9, and 4 are the coefficients up there. So if we bring down the 2, -4 times 2 is 9, and -8 is 1. -4 times 1 is... Okay, so now we have this completely factored. Does anybody understand how it looks now? This is 2x plus 1 is our last factor. What were the first two? X minus 5, x plus 4, and now we had left 2x plus 1. Does it go back and have the same leading coefficient and degree as we started with? If we fold that back together, would we get a 2x cubed? That's always important to check at the end, because I'm going to show ways eventually a lot of you will miss that 2 and leave it off of your answer. Okay, so you have this question. Ready to try this? It says it says graph first here. Let's throw that in, because do you really want to figure out if some of them don't work? How could you tell if those work real quick? For what? Yes. So they're suggesting that, because if they don't work, then our depressed polynomial won't work either. Thank you, Martin. That does help me. Go ahead, keep minus, oh, I gotta go back and arrow to the right.
Minus 15x squared minus 32x plus 12.
Okay, if I just look at a standard window even, anybody having trouble? My stat plot was on, I had to turn it off. Ooh, I think it's looking like -3, -2, and +1 all work. And then there's something in here that's not looking like an integer, right? How could I check that? Oh, +2 maybe. Okay, could I check those guesses? Just go trace -2, enter. Ooh, it's a 0. -3, enter. What did they give us for choices, by the way? Oh, 1, -2, and +2. Did those all work? Oh, it's good we didn't just start this problem, because is 1 going to work? No, it is not. We could have done it. It wouldn't have been pretty because we would have had to start over with a new factor. This one does not work. Now, it doesn't matter which of the next two we do first. Anybody want to pick? You want to do the x plus 2 factor or the x minus 2 factor? Okay, she wants to do this one first, so the +2 will go in the box. We have 3, 8, -15, -32, and +12. If this doesn't come out 0 when it did on the graph, then we did something wrong. If you do that on a quiz and you bring it up to me and you say, I know this is supposed to be 0, I can't find my mistake, I will try to help you find your mistake, because you conceptually get the idea, right? But I know I can do 2 times 3, 12 times and get 6, 5, 3 different times, right? So you got to just, sometimes you don't see your mistake. 2 times 3 is 6, 14 times 2 is 28, 13 times 2 is 26. I got 0. Did someone else get 0 after all my talking? Okay, but what do we do again? Remember, successive division means we now use this. Do not go back and start over. This is the depressed polynomial. Successive division means you do one right after the other, you keep going. So now what am I going to use? We did this, and this worked. But now I'm going to do this one. -2, right? Because this one would have a 0 of -2, and I keep going with the same terms. Bring it down this time. -2 times 3 is -6, add is 8, multiply is -16, add is -3, multiply is 6. Why was that helpful? Does anyone know? What's this leftover meaning?
That's the final factor.
Okay, so far I have an x plus 2 and an x minus 2 that match. That's not the order we did them, it doesn't matter. What does this leftover mean? Can you write it as a polynomial for me?
3x squared plus 3x.
Okay, I want this completely factored. Does that factor further? That gives me 9. Minus 1 is 8. Okay, so guess where that fourth factor, remember on the graph, there was a 0 that was at a funny place? It was at what? 1/3. Okay? To check when you're all done, because you will eventually find out that this can be a struggle, again, I had to have a 3 somewhere, because this is what, let me tell you right now, this is what someone will do. They'll graph it, and they'll write, there is 1 at -2, there is 1 at -3, there is 1 at +1/3. Okay, I just wrote those total, I just said those backwards of what I was writing. Let me try that again. The furthest left 0 was at -3, then -2, then 1/3, and most people would write x minus 1/3, and then at +2, x minus 2. This is wrong. Why is this not the factored form? If I FOIL that all back together, am I going to get this equation? No. And you can leave it like that, but you have to put the 3 back out there somewhere, okay? That's the struggle for students, is the leading coefficient still has to be the 3. So I would just, what we did, I would have written it 3x minus 1, but. All right, moving on. Synthetic division and remainder. So we have talked about this all already real quick. If the remainder is 0, then it's a factor. If the remainder is 0, then it's an x-intercept. And x equals c is a solution of the equation if you set it equal to 0. All right, there are 5 problems on the homework, but I'm going to do an example of each of the last 2 sections for you. This is supposed to be tomorrow's lesson, but we'll just have our work day tomorrow all the way through. Does that sound okay? All right, so the 2 questions, well, I thought I put them on here. Maybe I have them on a different slide. Okay, the 2 questions we're supposed to do are '53 and '59. Okay, which just go ahead and write them on your homework, because you're going to have to do 55 in a second. 53 is an added homework addition here, okay? Page 115, yes. Section 2.3. All right, number 53 says find the value of k so that each remainder is 0. Any ideas how we could do this?
Dividing by the bottom.
Yes, some teachers would tell you to do synthetic division. So you would put a 2 here, and then what would go across here, guys? Be careful. 1. The second one would be -1k. That's lovely. The next one would be 2, and the last one would be -4. Now, and it's supposed to come out at the end with what? 0. This is going to be a pain in the neck. Can I give you a better way? Does anybody remember the other way you can test if this is a 0? Plug a 2 into it, and it should come out what? 0. So, if I plug a 2 into it, f of 2 is supposed to come out 0. So, for number 53, I could just say 2 cubed minus k times 2 squared plus 2 times 2 minus 4 is supposed to equal 0. Does that look easier to solve? You don't know because we didn't go through the synthetic division, and I can. But this would be 8 minus 4k plus 4 minus 4 equals 0. Well, that's just gone. If I subtract the 8 to the other side, I have -4k equals -8. So k would be what? 2. So that's what they want to know. What is k? You want to see the synthetic way real fast? You would bring down the 1, multiply. Then you would have to add this. So you would get -k plus 2. Then you'd have to multiply that by 2. So you'd have -2k plus 4. Add that 2, you'd have -2k plus 6, multiply it all by 2 again, you'd have -4k plus 12, add this -4, and you'd get -4k plus 8, and then that would have to be 0, and you'd solve and you'd get 2. But I think that's a lot more complicated, because I probably would have made a mistake if I was you somewhere along the way trying to do synthetic division with a variable in it. So what are we going to do for 55? This is your actual homework. I would put in a -1, and set it all equal to 0, and then solve for k. Make sure you use some parentheses because it's negative. -1 cubed plus 4 times -1 squared minus k times -1 plus 1 equals 0. Then you're going to have to solve for k. All right. Give me a second. Anybody getting an answer? I got -4 in my little pea brain. No? This would be -1. This would be -1 squared is 1 times 4 is 4, right? -1 times -k would be plus k. Plus 1 equals 0. Isn't that -4? Did someone get -4? Okay.
I was knew that I had to plug in -1, but then still plugged in 1.
All right. I'm going to do 59 because you're going to do 58. It says, use the graph and synthetic division to completely factor this polynomial. Okay, 59 is this picture over here. Why is this picture going to help me factor this? It is a degree 5. Do you have any idea how to factor degree 5? The best chance you have is to get it down to a degree 2, because you can factor a quadratic, right? So how many zeros should I be dividing out? 3, right? What are 3 of the zeros from this graph? -6. Ooh, interesting. What's it doing right there? It's twisting, so I think it's a multiple 0, but 1 is definitely a 0, right? That's 2, thank you. It's counting by 2s. I think we might have to do that one twice, or actually it's going to come out as a 000, I think, but we're going to have to do it twice, because I don't know what that one is over here, do you? Not even. All right, so let's start with the -6. Ugh. -6. This is number 59, so our coefficients are 6. Do we need any placeholders? Oh, 13, -153, 54. I'm never going to fit this. 724.
Be able to extend the page that way.
That was the first step.
Minus 840? Okay. I'm writing very tiny. Bring down the 6. Multiply is -36. Help! -23 times -6. 138. Minus 153, or -153 plus 138. -15. Did someone get that? Else get that? A -15 right there? 43, 53, I think so. Then times -6 again is 90, I think. Added to 54 would be 144. Yep, I'm giving up. I need help. 144 times -6. -864. -140, maybe? Times -6 better be positive 840. Okay? Because we only know it's a factor if it comes out 0. Okay, if I were to write this new answer down, it would be degree what? We had a degree 5, and we divided out 1 0. So we're down to a degree 4, right? This would be the constant. This would get an x, x squared, x cubed, x to the 4th. Everybody okay? I don't know how to factor an x to the 4th. So what am I going to put in? Another 0 to this depressed polynomial. Keep going successively. So I'm going to do 2. Okay, I might be able to do this one. I don't know. Bring down the 6 times 2 is 12. Add is negative 11. Did I do that right? Negative 23 plus 12 is negative 11. Times 2 is negative 22. Did I do something wrong? Negative 37 times 2 is negative 54. Is 90 times 2 is 180. That's not right.
I think it's supposed to be 14 and not 11. Negative 14.
Right here? 6 times 2 is 12. Negative 23 plus 12 is negative 11. Negative 22 added is negative 37. Oh, that's because 2 times 37 is not 54. I was good until the end. 74, right? Negative 74, which that makes 70, which I can't write, I can say. Times 2 is 140. Added is 0. Phew. Now, I still don't know how to factor that because it's a degree 3. But do you remember what I said about this? Yeah, it's doing something funky there, so we're going to do a 2 again. All right, I got to erase that. I'm going to try blue ink this time. I'm going to do a 2 one more time and see if we get down to something we can factor. Bring this 6 down. 2 times 6 is 12. Negative 11 plus 12 is 1. 2 times 1 is 2. Negative 35 times 2 is negative 70 is 0. Okay, so at the moment I have x plus 6, x minus 2, and another x minus 2. And now I have left 6x squared plus x minus 35. And we're supposed to figure out how to factor that. I think it's going to factor with another x minus 2 and a 6x. No, it won't. X minus 2 won't work. It's made me 35. Man, guys, help. The bell's going to ring. Factors of 35 to make a 1 in the middle. Here, this works. Minus and plus. So it's 2x plus 5 and 3x minus 7. Nope, I don't think so. Oh, wow. So it wasn't, actually it was crossing at 7/3 once. Yeah. Okay, the homework one is 58, which is much clearer, maybe. It crosses at 0. I would say this is negative 5. And this is positive 3. So try those 3 first, okay? I don't think 0 works. You can't take an x out of all that.
This is not fun. Can we please get your page?
No, try 3 and 5 though. Negative 5 and 3. That should leave you 2 that you can factor. Lordy. Okay, that video is long and not good.
Oh, no.
So tonight you need to finish these problems along with the rest that were assigned on page 115.